Hey everyone, Dr. Nelson here. This is a video about deriving ordered pairs of functions. Okay, so the first couple pages of the notes you're going to work with me, so please stay with me, and then you'll have a couple problems to try on your own, and then at the end you can see how you did. All right, so our first function we have is y equals 2x plus 1. All right, so what we want to do is we want to create a list of domain and range values that make this equation true. All right, so I like to always use the first x value of 0. So what you do is you take that 0 and you substitute it in for the x. So 2 times 0 is 0 plus 1 is 1. So when the x value is 0, y equals 1. Let's try the number 1 for x. Okay, so 2 times 1 is 2 plus 1 is 3. Let's use the number 2 for x. So 2 times 2 is 4, and 4 plus 1 is 5. We can use, say, the number, say, 6. Okay, 2 times 6 is 12, plus 1 is 13. And I like to always use a couple negative values as well. So let's go with negative 1. So when x is negative 1, 2 times negative 1 is negative 2, and negative 2 plus 1 is negative 1. And let's go with, say, negative 4. Okay, so 2 times negative 4 is negative 8, and negative 8 plus 1 gives us negative 7. Okay, again, you can use any x values you want. I could use a million if I wanted to. Okay, so let's say if I plugged in a million down here, that means when I plug it in for x, 2 times a million is 2 million, plus 1 is 2 million and 1. All right. Let's try the second function. For this function, we have y equals 1/2 x plus 3. Okay, and notice now our coefficient is a fraction. So it's good to always use nice even numbers when you have 1/2 as the coefficient. So let's say, for example, we have x is 4. Okay, so I have to do 1/2 times 4. So I'm going to do this over here. So 1/2 times 4. And when I do that, remember, when you multiply fractions, you multiply across. So 1 times 4 is 4, and 2 times 1 is 2, and 4 divided by 2 is 2. Okay, so when I substitute a 4 in for x, 1/2 times 4 is 2, but then I have to add the 3. So that's going to end up with 5. All right, let's say if I use 8 for x. Okay, 1/2 times 8, or half of 8, is 4, and 4 plus 3 is 7. Say if I use the number 2 for x. Well, 1/2 times 2, well, half of 2 is 1, and 1 plus 3 is 4. Let's use some negative values here. How about if I use negative 2? Well, half of negative 2 is negative 1, and negative 1 plus 3 is positive 2. If I use negative 4 for x, well, 1/2 times negative 4 is negative 2, and negative 2 plus 3 is 1. And it's good to always use 0. So 1/2 times 0 is 0, plus 3 is 3. All right, if you turn the page, let's take a look at these problems. Okay, so here it says, which of the following points are solutions to the following function? Okay, so our function is y equals negative 2x plus 4. Okay, and the way we know it's a solution is if we substitute the x value in for x and the y value in for y. If the equations are equal, then you know that it's a solution. All right. So for point 1, 2, we know the x value is going to be 1, and we know the y value is going to be 2. So I like to always rewrite the function first. So y equals negative 2x plus 4. Now I'm going to substitute this 1 in for this x. So it's going to be negative 2 times 1 plus 4. It's going to equal our y value, which is 2. So now 2 is going to equal, well, negative 2 times 1 is negative 2, right? And negative 2 plus 4 gives you 2. And notice that 2 equals 2, which means point 1 and 2 is a solution, okay, to this function, all right? And here's the big idea. If we were going to graph this function, the y equals negative 2x plus 4, this point 1 and 2 would be right on the line. So far, yes, this is a solution. All right, let's try 4 and 4. So again, I'm going to rewrite the function. So y equals negative 2x plus 4. And then I'm going to substitute a 4 in for the x and a 4 in for the y. So 4 is y, so 4 equals negative 2 times our x value, which is 4, plus 4. And 4 is going to equal, well, negative 2 times 4 is negative 8, and negative 8 plus 4 is negative 4. So because 4 does not equal negative 4, it's not a solution. All right, so 0.44 excuse me, would not be on this line if you graphed it. All right, let's try 0.5 and negative 6. All right, so again, let's rewrite the function y equals negative 2x plus 4. And then I'm going to substitute 5 for the x and negative 6 for the y. So negative 6 equals negative 2 times 5 plus 4. And now negative 6 equals negative 10 plus 4. And negative 10 plus 4 is negative 6. And look at that. Negative 6 equals negative 6, which means it's a solution. Okay, let's try one last one. We want to know if negative 1 and 5 is a solution to this function. So let's go with, I'm going to go black for this one. So again, let's rewrite the function y equals negative 2x plus 4. And let's plug in what we know. So we know our x value is going to be negative 1 and our y value is 5. So 5 equals negative 2 times negative 1 and then plus 4. So 5 is going to equal, well, negative 2 times negative 1 is positive 2, and 2 plus 4 is 6. And 5 does not equal 6, which means this point is not a solution. All right. So now that you have a better understanding of ordered pairs and functions, okay, why don't you pause the video and try the your turn problems now, and really take your time with the problems. And then when you're done, hit play, and you can see how you did. All right. Good luck. All right, welcome back. Let's see how you did with these practice problems. Okay, so I did all the work out already. So take a minute and go over your answers. So again, the way we get these is we plug in the 1, right, for the x. So 3 times 1 is 3, plus 3 is 6. Okay, so we plug in a 2. 3 times 2 is 6, plus 3 is 9, and so on. All right, same thing with the fractions over here. So if x, let's say, is 4, if I plug in 4 here, 1/4 times 4 gives you a 1. All right, let's turn the page and look at the ones on the last page. And this time you determine if these were solutions, these points were solutions to the function. All right, and the first one, you should have ended up with 26 equals 26. And because they're equal, that point is a solution to the equation. All right, here you should have ended up with 3 does not equal 1. Which means that point is not a solution. Here you should have ended up with 8 does not equal 11, so that's not a solution. And then the last one, negative 4 did equal negative 4, so because they're equal, that is a solution. All right, how'd you do?